Hey, it's really amazing to have you here once again today. All right, welcome to my channel. Today we are going to be looking at this project. All right, structures and type dev in C. This is the project we are going to be looking at today. All right, it has been a while. All right, so what we are going to be doing here, we are going to first show you the quiz questions, explain them. Okay, we show you the quiz questions, explain them. Then we are going to look into giving a brief explanation on what structures are. All right, then before we dive into the project, believe me, all tasks are going to be solved in this project. All right, believe me, please watch to the end because all the tasks will be solved in this project. All right, let's get started, guys. Let's get started. The first thing we are going to do here, okay, for the project, once again, these are the project resources. Please ensure you look through them. All right, these are the project resources, and then this is the general requirement for this project. All right, like this is what we have here: a readme file. Test your code, test your code with Betty and ensure it follows the Betty documentation style. No more than 5 functions. The only C standard. All right, these are the only C standard library functions allowed. You have a main.c, the header file, and all that. So that's what we have there. Okay, so I'm going to just show the quiz section. Eventually, you haven't done that yet, and again I'll explain some things. All right, not just to show but to throw more light on what is in there. Okay, so here we have the general syntax for a structure declaration in C is, all right, this, and they're asking if it's true or false, maybe. All right, so for this definitely is true. All right, why am I saying it's true? If you look at what I have here, okay, all right, let me just use this opportunity to look through this. Said a structure is a user-defined data type available in C that allows to combine data items of different kind. Okay, structure declaration, you can define a structure in a global scope of your program outside of all your functions, just like the function prototype. All right, having said that, let us look at the general syntax for structure declaration. Okay, oh sorry, so this is what you have. This is the syntax. You have your structure, then you have a tag name for your structure, then you have this curly brace, then type. It can be integer, it can be float, it can be what else, string. All right, so you have your data type, member one. It can be not just 2, it's not restricted to 2, it can be 3 or more. Okay, then you have your, this is a comment, declare the very, this is a comment. All right, this is the general syntax. Okay, from there you have this. All right, so this is a character. You can give it a name. You can call it maybe my struct. All right, my struct. Okay, that could be a name for this. Okay, then you have another character, email, the integer, age, then you have your documentation, your comment section. So that's just basically the syntax for writing your structures. All right, that's the syntax. Okay, so again, coming back here, the general syntax, that means this is true. All right, this is the syntax. I believe that is clear enough. These two codes do the same thing. Is it true? Is it false? Okay, you have dev type dev struct point, then yes, then they initialize this with this value, with this alphabet, then this y. They initialize s and y as integers, then you have points. This is x. Take note, the first value here is x and the second one here is y. All right, then they use the point here. All right, y is 2, okay, yx is 1. That's true. X here is 1, y 2. So this is true, definitely true. All right, this is true. The two codes, they do the same thing. Given that we are here now, okay, given this code, all right, this is structure, the name, struct name, point, then you have your variable x and y, which are integers, okay. Then you have your this struct point 3 and 7, x is 3, y is 7. Then you have this. To see the member y of my variable, my underscore point to 9, to set that to 98, I can do any which of these is possible. All right, my point dot y, okay, is 98. Then my point, okay, for this will make us introduce the concept of, okay, I was thinking I'll explain that later. Let me just chip that in quickly. All right, that will be useful in looking at this, okay. Yes, so that will be to explain that question. That we will be talking about pointers to structure, okay. To do that, to access element of a pointer to a structure, you have to difference the pointer as they access, then access to the data using the symbol dot, the dot symbol. But there is a way to do that, okay. I believe you should be familiar with the concept of difference, okay. Difference, I believe that you should be familiar with that concept, this concept of difference. I believe you should know that. What is difference? You know, when you are working with pointers, pointers manipulate values stored at the memory address of the point to. All right, so the process of manipulative values, you declare the value, you come down, you change that value, you manipulate that value, that initial value you declared. That's the process of, you know, difference. So pointers, they manipulate this value, and this process is called difference. To do this, you use your operator. You use this operator, your asterisk. All right, this is what you use for difference. You use your asterisk. All right, that's the concept of difference, okay. So if you understood that, then there is a way you can differ without following the main what you know about difference here. Okay, just hold on, let me highlight that. Oh, sorry. Okay, you can just look here. This is the standard way of differencing, okay. You use the asterisk, okay, but for this you can difference using this symbol. What's that? Let me point that out to you, okay. You can difference using this and the greater than sign. All right, you can difference using this, okay. So instead of using your asterisk, then coming here to do maybe point, doing that, closing that, all right, then coming back here to do dot name, you can just simply come here and do this p, your pointer, then you do your dash, you put that symbol greater than sign, and you do your name, okay. So this does exactly the same thing as this. All right, that's the concept about difference. I just needed to show you that. So there's a simpler way to do that, just by using this symbol, your hyphen and greater than sign. This symbol is equivalent to differencing plus using your dot. All right, so I just needed to show that, okay. So have we sent that? Let's jump back here. Let me just clear. Okay, so you can have this. So this my point.y, this help you to accomplish this. Then this asterisk.y for differencing. Okay, then this is another method. This is an alternative method, for me an easier method to difference, all right, and assess this value, this 98. All right, so this and this are correct. Okay, I believe that is explanatory enough. So for the last question, you should write documentation for all your structures. That's true. All right, you should have documentation for all your structures. I explained that initially while we started. As soon as I write my structure, I should write documentation. This is true. All right, so I believe this should help you. Apart from just showing you the code, I've taken time to do some explanation, all right, on the quiz. Okay, I believe that should suffice for that. All right, so the next thing we are going to do now, all right, is to jump back. Okay, looking at the tags, we have 0 to 5. That is about 6 of them. Okay, so let's quickly look at the concept of structures. We are solving the tags after now, so all of them. Let's look at structure briefly. What are structures? A structure is a user-defined data type available in C that allows to combine data items of different kinds. Okay, it helps you combine data items of different kinds, more like function declaration. All right, a type of a user data that allows you to combine data items of different kinds. Okay, you have your int, your character, your car, your string, and all of that. Okay, so I have showed you how to declare a function. We'll talk more about that. All right, this is what is here. Okay, so I believe this little explanation, okay, will help you. It will go a long way helping you understand what we are going to be doing, because after now I'll just show you how to solve the task. All right, so let me shut this down. And okay, so I'll get a terminal. All right, so after doing that, I'll come here and then I'll navigate into my ALS low level programming. First, let me be sure I'm in the root directory. Okay, you always have to ensure you are in. Okay, I'm very sure I'm in the root now, so I'll cd into this GitHub repo. I'll copy this using Ctrl C. I'll get back here, Ctrl AV to do that. All right, then after that I'll move it to this directory. Okay, for you don't have that directory, so first we are going to create that directory. All right, though I have that already, so we are going to make this directory. All right, so I'll copy this, I'll come back here, I'll use mkdir arrow, make directory, then I'll paste the name of the directory I intend to create or make, as the case may be. So if I press enter right now, it will tell me that cannot create because it already exists. All right, so I created that before now. To be sure for you to know that it's there, if I list items there, you see it's there. All right, so if you don't have that, you have to create it using mkdir make directory, and you know to have that. So since I have it, I'm going to navigate it to that directory using change directory cd. I'll paste the name of the directory I intend to navigate into. All right, as you can see, we are now into the structures and typedef directory. All right, so have we done that? We now go ahead. The next step looking at our requirement or instructions, we are going to create our readme.md file. Okay, so we create our readme.md file, then we start creating the individual files. All right, how do we do that? We are going to use vi to do that. Okay, so I'll do vi readme.md readme.md. okay, so if I hit enter, you see that okay, this is the content of my readme. How did I get this? Like I would always say, this is simple. You come here, I just merely copied the tax names. All right, this is what is here. So this title, I copied it from here, Ctrl C, then I put it in my notepad, put that in my notepad, I pasted it here, then I'll move down here, move down, copy this tax name and what is expected to do, write a function. I'll copy that, then copy this, doc teach you that, and the question, write a function, this, copy all of that. So when you put all of this together for all of the tasks, copy 3, 4 and the requirement. So when you do that successfully, you should arrive at this. So you paste it in your notepad, you copy everything and paste inside your readme.md file. So that is how I got this. As simple as that. I believe you can do that. So when you are done, when you've done that successfully, you have that here, then you can move out of here by doing escape column WQ. You write save and quit. All right, so once you are done with that, that means you have successfully created your readme.md your readme.md file. All right, so the next step is to create your individual files. All right, to create your individual files. So the first one we have there is the doc.h file. Okay, the doc.h file. That's what we are going to do first. So you simply come and copy that file name using Ctrl C. So you come back here, you do vi Ctrl AV. Okay, don't worry about this. I'll just go ahead and recover that. All right. Okay, that one. It shouldn't be. You will not see this. All right. Okay. So once you do that, you copy that. You copy your file name and put it there, and you come here. All right, then you go ahead and put this code into that file. This is, we are including the if not def. This stands for if not def. All right, let me show you that. I can't write it. Let me just put it here. So what you are seeing there, if NDF stand for if not def. All right, if not defined, that's what you have there. Then defined. So these are the headers we have here. Okay, these are the headers we have here. This is your comment, your documentation. You comment here. All right, then this is your structure name. Struct, you use struct to define that, to introduce that. Okay, then you come and declare your structures. Okay, these are the name. Okay, structure. These are the variable declaration. That's it, the variable declaration. Okay, and the type, in C you have to indicate the variable type. Okay, this character, this float, this character. All right, these are variable declaration. Then what do we have here? These are the prototypes. Okay, the prototype. I believe you should know how to get that by now. All right. Yes, these are the prototypes for all. This is the first one. Okay. Oh no, this is the, you have to put this. So you have to put this first. I believe that's what we have there for the first one. Then you put this. Then you have then this is another prototype. So you carefully select them out, copy them, and put them into this file. All right. So this is another prototype. So you put them into that file. So when you are done, this end with end if. So you escape, you do column WQ. I'll simply quit. All right. Just hold on. I'll do that now. Okay. You shouldn't see this. I have some swap files. That's why this is fighting with me right now. So column Q. All right. Okay, I'm just trying to find a way to escape from here. I'll do that. Escape, scroll down. Alright, so yes, so having done that, the next thing you are going to do here is to come and do your Betty. All right, you are going to come here, do your Betty, then file name. All right, Betty, then you put in your file name, the doc.h. You do your, you run your Betty to ensure that your Betty, your code meet the Betty standard, is Betty compliant and follow the Betty documentation style. So when you do that, if it's successful, mine once you do that successfully, then you can then come here. Oh, after doing that, then sorry, I'm skipping a step which ought not to be. Once you do your Betty, if it's correct, you can then come here and do git add dot, you press enter, git commit, -m, your commit message. Of course, we are going to use doc.h. all right, doc.h. You press enter. All right, after putting in that, then you can then go ahead and do your git push. I already did all of this. All right, you go ahead and do your git push. So after pushing your code, you can then come here and check if it's correct. All right, you can then come here and run your check. Okay, so for this, I say stick. So if you run that, you see, so if you follow this step, you are going to get it correct here. All right, to be all checked. So let me close this. So move to the next next task. If a dog is the only thing on earth that loves you more than you love, a dog is the only thing on earth. Alright. They are making a lot of assumptions here. Write a function that initializes a variable of type struct dog. This is the prototype. Alright, which we already put into our dog.h file. Okay, so I'll just go ahead and copy the file name using Ctrl+C. I'll come back to my terminal, VI, I'll paste Ctrl+AV. So if you enter, your screen should be blank once you come here. So you are going to, I'll leave the document, the codes in the description to this video. Alright, so we have this. We are including our standard library.h, then we are including the dog.h file. Alright, this is what is in our header file. This is your comments. Okay, are your comments. Alright, then this is your structure. Alright, structure declaration. Okay, structure declaration. Alright, then you are including this prototype. That's what you have here in this first line. We included this prototype here. Alright, then if d is exactly none, d equals to malloc size of structure dog, then we used this. You understand what we explained earlier about we explained that pointers to structures, that you can use this symbol, your dash and greater than, to replace to do differencing instead of using your asterisk and all that. I explained that earlier. Okay, so that was what came into play here. Okay, that was what was done here, just as simple as this. Alright, they used this symbol, to difference instead of using your asterisk and dot the name. Okay, so that's what happened here. So after putting this into your file, you can then escape :WQ to save and quit. Alright, then you can come back here. Let me undo your Betty file name. So paste Betty file name. You check if your code is in line with Betty requirement. Alright, so Betty is checking. Alright, you can see this is in line. Didn't return any error, so this is in line with Betty. So you can then go ahead and do your git add dot, press enter. After that, then you do your git commit. Do your git commit commit message. Of course, we use the name of our file. You press enter, then you can do your git push. Then you can do your git push and press enter. Once you are done, then you can then return here to check your code if you do that rightly. So checking with us right now, you see it's all correct. Alright, so if you follow what the step I outlined, you should get the same result. Alright, so close this and then move to the next task, which is 2. A dog will teach you unconditional love. If you can have that in your life, this would be too bad. That's cool anyway. Write a function that prints a struct dog prototype. This is the prototype. Alright, so the next thing we are going to do, go ahead, copy this file, Ctrl+C, then come back to our terminal, VI, Ctrl+AV to paste that in. Press enter. Alright, so this is the content. We are including our standard input output header, then we are including our standard library header, and we are including dog.h. Okay, then this documentation or the comments. Alright, then these are prototype. Alright, this line is our prototype that was given here. Okay, yes, this prototype that was given, that's what is there. So then you have all of this. Okay, conditional statement: if this is null, return this. If this is pointer to a structure pointer, okay, then this nil, this another pointer. The series of pointers we use here. All right, then printf, output this name, then string age, or output this. Okay, so that is what you have there. Once you put this into that file, you can then do your escape wq. Just use q to quit. All right, so having done that, you can check for Betty file name to confirm if your code follows the Betty style. All right, it does. It didn't return any error. So having done that, you can then go ahead to git add, enter, do your git commit, and your commit message, press enter. Then you can then go ahead to push your code to the remote repo. Git push, press. Once you tap enter, your code should be pushed to the remote. Then after you do that, you can come back and check your code. All right, so I'll just run this check right now. All right, you can see it's all checked, it's all correct. Okay, so I'll close this. We'll move to the next task. Define. Okay. Outside of a dog, a book is a man's best friend. Inside of a dog, it is too dark to read. Define a new type, dog underscore t, as a new name for the type struct dog. All right. So this file, dog.h, I believe we have that file already. We have that file already. So I'll move to the next one, please. A door is what a dog is perpetually on the wrong side of. Write a function that creates a new dog. Okay, so that's the prototype. This is the prototype here. So, and they say if you have to store a copy of name and owner, return null if the function fails. Copy the file name. All right, go ahead to copy the file name using Ctrl C. I'll come back here, I'll do vi, paste that, Ctrl A V, press tab. All right, so again, this is the content of this file. Okay, I'll leave the documents in the link. All right, we are including a standard library .h, then include the doc.h file. Then these are documentation. All right, then these are variable, the name. All right, we are using for this function. All right, and this is the type, it's an integer. Then these are arguments. All right, these are arguments or our parameter. So we are initializing I, and we are giving I the value of 0, and why this is not equal to 0, increment I plus plus, and return I. So that's what you have there. And I'll leave the code, you can just look through. Let me do page down. Lengthy though, I'll leave the code in the description to this video. So once you are done with that, you can do your escape, then :wq. All right, then you press enter, which then you can go ahead and run your Betty, Ctrl A V, Betty file name, then All right, you see Betty is checked off correctly. It didn't throw any error, so that means our code follows the Betty style and Betty document, the Betty standard. All right, it's Betty compliant. So having done that, you can then go ahead and do your git add, enter, do your git commit, your commit message. Of course, we use our file name. You press enter, then you do your git push to push to the remote. If you press enter, that will push your code. I've done that before now. So once you press enter, to push your code to the remote, you can then come back here to check your code. So let's run and check. You see, it's all checked. It's checked correctly. So please follow this. If you are lost, or if you miss out at any point, replay this video. It's going to guide you. All right, it's going to guide you so that you can get the same results. All right, the same result I'm getting right now. So I'll close this. I'll move down to the last. I believe this is the last task. How many legs does a dog have? If you call his tail a leg, I believe this is a popular question or prank, something like that. If you call the leg 4, saying that a tail is a leg doesn't make it a leg. Write a function that frees dog. Prototype is there. All right, so just go ahead. How do we do this? First and foremost, copy my file name using Ctrl+C, then I'll paste here, Ctrl+AV. Sorry, I'll have to add vi. Paste that. I'll press enter. All right, this is the content of this file. Okay, this is just the content of this file. All right, this is the content of this file. So I believe we have explained from our previous explanation. You should be able to know what is happening here. So this is for this function or structure, which is not really okay. For this function, it's void. All right, you can call it of course a structure, you know, in a function format. All right, the type is void, and this is the name, free_dog, and this is the argument. All right, all these are embedded in the parameter in the prototype that was given here. Look at it. All right, this is the prototype that was given. So this is a function. So this is a function. We are right if you call it a function. And then here, if d, right, this argument, then free d. Okay, this is the symbol we talked about that can be used instead of for difference, instead of using your asterisk and dot. All right. So this is what was done here. All right, so once you are done, you can do your escape :WQ. all right, so you quit from here. You can go ahead and check if your code follows the Betty style. All right, if I put that, I'll press enter. It's checking for Betty. All right, it didn't return any error. That means the code is Betty compliant and followed the Betty documentation style. Having done that, you can go ahead and do your git add, enter, then do your git commit, put in your commit message to AV file name, of course, then you press enter. Then you can now do your git push. Once you press enter, that will help you push your code to the remote repository. All right, I'm not pushing again. I've done that before now. So once you've done that, you can then come back here to check your code. So I'll run this check again. All right, so it's all checked. It's all checked. So follow this step. Follow this step to get similar results. All right, so I'll close this. All right, so please like and subscribe to this channel. It's very important because every now and then we bring out similar videos to guide you in this journey. All right, it's a very tough journey. Software engineering is not it's sometimes it can be, you can see it as something that's difficult. That is why we have channel like this to help you, to get you, to keep you on that journey. All right, I believe that this video have been helpful right from the beginning. I believe you've gotten value from this. Please give us a thumbs up. All right, comment, drop your comments in the comment section, drop your questions, we give answers to them. All right, give answers to them. All right, so I believe that this will be helpful. I will see you in the next video.